In example 3, we have a word problem. A Superslide charges $1.25 to rent a mat and 75 cents per ride. Jason has $10.25. How many rides can Jason go on? Well, first of all, we're going to let R represent the number of rides. So we're going to write the inequality. So we know he's going to pay $1.25 plus 75 cents for every ride, and it's got to be less than or equal to $10.25 because that's as much money as he has. So now we're going to solve this problem. So we have $1.25 plus 0.75 R is less than or equal to 10.25. I'm going to take $1.25 away from each side to make that a zero pair. I get $9 on the right-hand side. Now I want to get R by itself, so I'm going to divide both sides by 0.75. R is less than or equal to 12. Because I divided by a positive number, I don't have to change the inequality. I'm going to draw my graph. Now I have a word problem, so I have to ask myself, is this going to be discrete or continuous? This example where you're taking rides on a slide is going to be discrete because you're going to go all the way from the top of the slide down to the bottom. You're going to pay for the full ride. You're going to take the full ride. So I know this is going to have to be discrete. So I'm drawing my number line with all the numbers on it because I know I can't take something like 6.5 rides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. I'll put a few more numbers on. And this time I'm going to put dots everywhere that represents a ride or a number of rides that Jason could have taken. Now Jason could also, for his 10.25, have taken no rides, so I'm going to include 0 this time. It doesn't make sense to include any negative numbers because you can't take a negative amount of rides. So that's the solution to this word problem.